Hello everyone, this is Jyotsna. Welcome back to my YouTube channel. In this tutorial, we will see about the detailed explanation about the integration testing. Integration testing is a second level of testing. In our previous tutorial, we have seen about the unit testing, which is the first level of software testing. Here, the integration testing is second level of software testing, which is usually done by the developers. However, in organizations that have implemented test-driven development, tester may also take part in integration testing. In this testing, units or individual components of the software tested in a group. The focus is to expose defects at the time of interaction between integrated components or units. Here, the integration testing focuses on checking the data communication among these modules. Hence, it is termed as I and T, which is integration and testing, or string testing, or sometimes called as thread testing. In this image, we can see there are different modules, module A, B, C, which are tested in a unit testing. In integration testing, we combine those modules under um, and do the integration testing on those modules, combined modules. The next is why do integration testing? Although each software test modules is tested in unit testing, defects still exist for various reasons. For example, a module in general is designed by the individual software developers whose understanding and programming logic may differ from other developers or programmers. So integration testing becomes necessary to verify the software modules works in Unity. The another reason is at the time of model development, there are wide changes in requirements by the clients. So these new requirements may not be unit tested and hence system integration testing becomes necessary. So here the interfaces of the software modules with the database could be based on the wrong information. This is one of the reason we do the integration testing. Also the external hardware interfaces, if any, could be based on the wrong information. Also, inadequate exception handling could cause issue with, unit testing. So we need the integration testing here. The next is integration testing techniques. So integration testing may be black box, white box, or gray box. In all the these black box, white box, gray box techniques comes under integration testings also. So there are different black box testing techniques such as state transition techniques, decision table techniques, boundary value analysis, all pair testing, cause and effect graph, equivalence partition, error guessing. These are the some of the types of black box testing which we use under integration testing. And in white box testing, we use data flow testing, control flow testing, branch coverage testing, decision coverage testing under the integration testing. There are different integration testing approaches. Uh, I have mentioned here four different integration testing approaches. First is Big Bang approach, top-down approach, bottom-up approach, and hybrid, or we also called it as sandwich approach. We will see one by one what are these different types of approaches. Before going to the approaches, first we will study about stubs and drivers, which we use while doing the integration testing. So stubs and drivers are the dummy programs in integration testing used to facilitate the software testing activities. These programs act as a substitutes for the missing modules in the testing, the modules which are not yet developed. They do not implement the entire programming logic of the software modules, but they simulate data communication with the calling module while testing. So here stub is called by the module under test, and driver is a calls the module to be tested. In this image I have given here here is the main module which is under construction, and this is the driver which is a part between the main module and the sub modules. So for stub, if any of the sub module is under construction, then we take sub as a call program for the sub modules under which are under construction. The next is first approach, Big Bang approach. As the name said, it is also called as system approach. All the modules of the system are simply put together and tested in Big Bang approach. If once an error is found during the integration testing, it is very difficult to localize the error, as the error may potentially belong to any of the module being integrated, because we are keeping all the modules together in the system and then testing it. So it will be hassle to locate the error. So debugging errors reported during the Big Bang integration testing are very expensive to fix. There are some disadvantages and advantages for the Big Bang approach. Advantages is that it is convenient for small systems, and disadvantages includes it is difficult to detect the module which is causing an issue, because there are different all the modules are combined together for the testing. It requires all the modules all together for testing, which in turns leads to less time for the testing, as designing development integration would take most of the time. Testing takes place at only once, which thereby leaves no time for critical module testing in isolation. So these are some of the disadvantages of the Big Bang approach. The second approach is top-down approach. The process of testing a topmost layer of software first is called the top-down approach. Here, the program is tested from top to the bottom. First, parent module and then child modules are developed. While interconnecting child modules with parent modules, if there is any sub-modules is under construction, then that developers create a temporary program that is called as stub or call program. In this image here, stub is given. The third approach is bottom-up integration testing. The process of testing a very lowest layer of software first is called a bottom-up approach, as the name suggests. Program is tested from bottom to the top layer, while first child modules and then parent modules are developed. While interconnecting child module with parent modules, these child modules are sub 1 and sub 2 and parent is main module. If there is any main module is under construction, if this module is under construction, we take driver as a intermediate or temporary program, which is called driver or calling program. The third approach is sandwich integration approach, which is also called as hybrid approach or critical path first approach. So here both top down and bottom up approach are combined. Both approach starts simultaneously and testing is built up from both sides. It needs big team because we are using both top up and top down and bottom up approach together. So this image shows the same main driver, which is if main is under construction, then we'll take driver as a calling program, and here for sub which is sub program, if there are two different sub programs from which any of the sub program which is under construction or sub model is under construction, then we take temporary stub which is call program for the for testing of this sub one module. Next is how to do integration testing. So prepare for the integration testing. First we prepare the integration test plans, then we design the test scenarios, cases or test scripts. Then executing the test cases followed by reporting the defects. The next one is tracking and retesting the defects. And after that, step 3 and 4 are repeated until the completion of integration is successful. Means executing the test cases followed by reporting the defects and tracking and retesting the defects. So this is how we do the integration testing. There are some entry and exit level criteria for the integration testing. For the entry level criteria includes unit tested components or modules, all high prioritized bugs fixed and closed, all modules to be code completed and integrated successfully, integration test plans, test cases, scenario to be signed off and documented, required test environment to be set up for integration testing. So this is for the entry criteria. For exit criteria, we check the successful testing of integrated application. We check that executed test cases are documented, all high prioritized bugs fixed and closed, technical document to be submitted followed by release notes. These are the 4 points which comes under exit criteria. The next is best practices or guidelines for integration testing. The first At the first, we determine the integration test strategy that could be adopted and later prepare the test cases and the test data accordingly. Study the architecture design of the application and identify the critical modules. These need to be tested on priority. The third one is to obtain the interface design from the architecture team and create test cases to verify all of the interfaces in their details. Interface to database or external hardware or software application must be tested in details. Next one is after the test cases, it's the test data which plays the critical role. The next one is always have the mock data prepared prior to executing. Do not select test data while executing the test cases. So these are some of the best practices or guidelines for the integration testing. There are different tools in market which we use for the integration testing, which is for the automation integration testing. I have given some of the tools here: Citrus, Fitness, Protractor, Rational Integration Tester, and Tessie. These are some of the integration tools which are widely used in market. Thank you so much for watching the video.